guys, welcome to another video bi-weekly contest 165. So it was a good contest. First two problems were pretty easy, but yeah, third and fourth were pretty challenging. So let's dive into the video. Question for LeetCode BiWeekly Contest 165. The smallest absent positive integer greater than average. So what does it say? First of all, you are given an integer array nums. Okay, so let's say 1, 2, 3, standard test case. And at max, the size can be up to 100, minimum 1, the size of the array for any given test case. And for again any given test case, the integer values, that is the elements inside, can be between minus 100 to 100. So those are the constraints. Now let's move on to the problem. So what you are expected to do is to find the smallest positive integer that is greater than average of these sums or nums. So what does it mean? First of all, what is average? We know average is that sum of a set of group of elements divided by size, the frequency. So here the sum is going to be 6, 1 plus 2 plus 3 is 6. Apart from that, size of the array is 3, so 6 by 3. Here the average is 2. Now let's say our answer is x, right? So this x is nothing but the smallest positive integer that is strictly greater than x, that is 2 cannot be equal to x. Okay, so it should be at minimum 3. So over here, when you think you obviously can't start with 1 or 2 and then you go to 3, you see 3 is greater than 2. Yes, it is greater than 2, but it's already inside nums. That is one constraint. It should not be inside this integer array nums. So you move on to the next index. So next positive integer will be 4. So 4 is greater than 2. Yes, it is greater than 2. And 4 is not inside nums. Okay, it's not inside nums. So that's how we return 4 as the answer. Now, how do we do this? The naive approach, very brute force approach, would be running a for loop. First of all, you will obviously calculate the average is equal to sum of nums upon len of nums. And then you would run a basic for loop and then check each and every time if that current element, that is, let's say that element x is in nums. If 1 is in nums, yes it is. If 2 is in nums, yes it is. If 3 is in nums, yes it is. If 4 is in nums, yes it is. Not there, so we'll return 4. That's the brute force approach. But how do we optimize this? The optimized approach is very much similar. So now this is for like beginners. So there's something called a set. This is a data structure. What does it do? Basically, it stores all your elements inside a data structure and it gives you O1 lookups. What is O1 lookup? So in time, this comes under time complexity. It basically, in simple terms, you can just assume that each and every element you find, if you want to check if it's there in the given array nums, it's super fast. And that is exactly O1, that is constant speed. But when you look at an array rather than look at using a set, it would lead to ON because it has to search each and every point in the array. So moving on to the actual approach. So first you'll find the average, then you'll make up a set. Let's say the set is something called S and it is set of nums. This is one approach, and then until here we are done. We'll be able to check if that current element, the element which we have to find, is there in nums. We also have an average to compare. But now, what is the range? From where do we start and where do we end? That's the question, right? So when you think about the constraints, it's given over here that minus 100 and 100 is the range. So it can be proven mathematically that at max 201 iterations is to be done. minus that is 100 in negative, 100 in positive, and 0. So 100 elements plus 1 element plus 100 elements, 201 elements. At max, this is going to be your n value. But can we do better? Can we do better than 201 iterations? Yes, we can. How can we do that? So 100% mathematically, if you think, for finding an average of a set of nums, it's always going to be greater than as in it's always going to be lesser than or equal to maximum of nums, because when you're going to take the average of a sum of elements inside nums, it's going to decrease the value. Let's say you're given 3 comma, or let's say you're given 10 comma 1 or 10 comma 2. So size is 2, sum is 12, so 12 by 2 gives you 6. The maximum possible value is going to be 10 when then the only element is 10, because 10 by 1 gives you 10. So 100% the maximum value which you're going to get inside is going to be 10, the average. So by now you would have been clear that the maximum possible value which we have to return would be maximum of nums plus 1, because what if 10 is there in nums? It's there, so you can't return it, so you'll directly return 10 plus 1, 11. So that's the idea. So you're on a loop. So this is the algorithm. Run a loop from 1 comma max of nums plus 1. You check if I, let's say run I loop, is not in the set. Also, if it's not in set, then you'll check if that I is greater than average. If it's greater, then you'll return I directly. Now what if you do not find any element up to this, which means up to maximum of nums? It means that your average is maximum of nums, right? So you'll directly return max of nums plus 1. So this is your answer. Now let's discuss the time complexity. So this, I'll tell you in detail each and every iteration. So for finding average, we are calculating two things, the sum and len. Len is not a problem, it's going to give you an O1, and then sum is going to be On, because you'll have to add each and every, even in inbuilt libraries, it is going to be adding each and every element. So that is one On, and then we are using a set to optimize our approach. So this again will take an On for adding inside, because each and every element will have to add, right? So that's like taking each and every element to consideration. So we are adding. However, at end it will give you O1 operation only to figure out. And then this is one On and this is another On, and then our limit. So we'll be taking the end limit as maximum of nums, right? So to find this maximum would take another On. Again, you can optimize it over here by finding in sum of nums itself, where you can iterate inside the array, and you can keep a count, increment each and every value for nums, nums of I, and then you can take the maximum value accordingly. That's pretty straightforward. So it's like, again, if you want, you can take it or not, and then you have to run a loop from 1 to max of nums plus 1. So this drives the time complexity down to On plus, it's actually going to be O2N, but as per standards we don't take O2N, we say On plus max of nums. So finally, this can call as on itself, and space complexity is obviously going to be on, because at worst case scenario all elements are going to be unique, so it's going to be on. That is, we are using a set over here. So this is a detailed breakdown of problem statement 1. So we start by taking the average, that's the summation, that's sum of all elements divided by the length of the array, and after that we'll be taking the set of all elements, which allows us to look up if an element is there in an array in O1. And here we are taking max of 1 comma the maximum of nums, which I hadn't mentioned earlier. So why are we doing here this is because there might be a condition where the length, as in the elements inside, can only be negative, because constraints say it's between -100 to 100. So what if the elements are like -32, -33, -34? In that case, maximum will be -32. So when we run a loop from 1 to maximum of nums, so it's going to be 1 comma -32. The loop won't even run, and we return simply the maximum plus 1, so it will return maximum, it will be -32. -32 plus 1 is -31, which is totally wrong, because it should be positive, so it should be 1 as the answer. So that's why we are taking maximum of 1 comma max of nums. That's what is required. So moving on, we run a loop from 1 to the limit, as I mentioned, the max of nums, and we'll check if the element I is not in S, and if it's not in S, we'll be also checking if it's greater than average. If it's greater than average, we'll return I, or else we'll return I plus 1. So yeah, I guess you can directly submit it. It should be working, and yep, all set. Moving on to the next question. And here is the next question for biweekly contest 165. That is minimum discards to balance inventory. So what does it say? First of all, you're given an integer w and then an integer m and an array arrival. So let's say let's take the director's case given the contest. That's 1, 2, 1, 3, 1. This is the array. Now you're given w equals 4 and m is equal to 2. Now, what are you supposed to do? First of all, what is W and what is M? Now, the biggest pain point in this problem was not actually finding out the solution, but understanding the concept itself, like what the problem expecting. So, first of all, to understand this problem, that's a prerequisite of you knowing sliding window. If you know sliding window and if you have an idea of how it works, you'll be able to implement it. So, that's one of the prerequisites. Make sure you know it. If you don't know, please do watch a video on sliding window approach and be back. Let me just give a quick intro of what the sliding window is. So, you want to do some operation, right? Let's say there's A, B, C, D, E, F, and you want to do some operation on these particular group of subarrays. So there are two type of conditions categories in sliding window. One is a fixed window, another is a dynamic window. A fixed window is the simpler version of sliding window questions. That is, you always take a group of elements. Let's say the size is 3. You always take that group of 3 and you keep on moving. So it's A, B, C, and you just remove this element. And B, C, D, perform your operations, and C, D, E, perform your operations, and D, E, F, and perform your operations. Now, a dynamic window is where you keep on increasing and you might decrease as well, depending on the question and the operations you perform. Let's say I increase until D, and then I realize that I don't want any character which starts, with A or B. Then I keep on decreasing until that A or B is found. So that's the basic idea of how a sliding window works. Now, what are they saying? You are given an array arrival, you are given W, that is of the window. So 1, 2, 1, 3 will be one window. 2, 1, 3, 1 will be another window. And what is this 2? This 2 is nothing but the maximum possible size and element's frequency can be in a window. So when we take this particular window, at max, so 1 is coming twice, right? Now if it comes thrice, that window is going to be considered invalid. Same way, 2 is coming once, so it's valid. 3 is coming once, it will be valid. So 1, 2, 1, 3 is valid, because even 1 is coming twice only, it's not exceeding n. If it's equal to m or lower than m, it's fine. So this is the basic idea. Now what do you do if that particular, let's say the frequency of any element y is x. So this is the element, this is the frequency. Now you find out there's an element y.
You increment the count when you figure out y, and that count is going to be greater than m. So let's say that frequency of that element is greater than m. This is where you will discard. As and when that element comes inside the window, you will discard it. If it's not, as in if it's lesser than or equal to m, that's when you'll accept it. So this is how you go forward. Let's discuss another test case to understand it better. Now here is another test case. So let's visualize how the flow of execution is going to be. By the way, this is basically a sliding window plus a simulation problem. So it's super easy to implement, but you just know how to implement it. So window size is 3 and the maximum frequency which can be is again 2. So you go 1, you put it. So once, let's say these are the elements, right? Oh wait, it's not visible. One second. So let's say these are the elements over here. This side indicates the elements, this side indicates the frequency. So here 1, so far we got 1. So it's accepted because 1 is less than 2. And then we increase the window. 2. 2 is again 1. And then again we increase the window. 3. 3 is again 1. Now you are going to shift the window. Why? Because the elements are exceeding, right? The window size is exceeding. So when you reach 4, you will pop it out. This particular element will be popped out. So now 2, 3, 3 is that. 1 is 0 right now. 3 is twice. So again it meets the constraints. 3 is frequency is 2. It's under the constraints only. Now when you reach this window, first you'll pop this out. So 2 will become 0, now 3 will become 3. So element 3 will have 3 as the frequency. Now you can see that 2 is obviously greater than 3. 3 is obviously greater than 2. So this is where an hit occurs. Now you'll have to discard it. The arrival value is what you'll discard. They have clearly mentioned in the question that if keeping the arrival on day I would cause it to appear more than m times. If keeping the arrival I of ith element would cause it to appear more than m times in the window, then that arrival must be discarded. So that's the main. So you won't consider this. You will pop this value. This will become 2 now. When you shift it, here is where you have to pay attention. You are going to shift it. This element will pop out again. So 3's frequency will be 1 and 4 will be added again, so it's going to be 1. So even though this is our window and we are accounting for all the elements and the frequency inside, 3 won't be included. Only this element and this element will be included. Why? Because we remove the arrival element and we pop this out, so only this window is there. This window has only this one 3 and this one 4. So that's how it works. So here is the algorithm. You'll run a loop from 0 to w, and for let's say each element is considered as x in an array. So 1, 2, 3, 2, 2. So here let's consider this as x will be 1. So you will increment the count in the frequency. D is nothing but the dictionary which we are using. D is equal to the dictionary, or in other words the unordered map in C++. So you will be using it. Now with each element you will increment the frequency, and you will check with every increase, with every figuring out, like coming across every element, you will check if that frequency of the current element is greater than m. If it's greater than m, then we will remove the arrival of that element. So that element itself will remove from the dictionary. Now, and with every removing of element will increment the answer. This will create for the first window, and you'll do the very same approach for every other window. Now you again run a loop from W10, perform the same operation. Just one addition is that you'll be popping now. You'll be adding the elements like this. You'll add it over here. Add nums of I. So that's the rightmost index, and then you will pop the leftmost index. So let's say 1 to 3, you will store 1 to 3 over here. These elements would be stored accordingly over here, and then when you start from 2 and so on, it will pop out this one value alone. For that we'll be using L. I'll explain the code base as to how we are going to implement the code. So it'll take 2 3 2, accordingly it will pop. But caution guys, the solution is not yet over. One does a very big edge case that we'll have to account to. It's not even an edge case, it's a proper observation which you'll have to account for. I myself got a penalty for which I did not figure out earlier. So as I mentioned, we'll come across index. Let me give you a better test case to understand. So let's visualize what's happening over here. So R would move forward, 2 is accounted, so 2 would become 1 in frequency, and with this arrival it will become 2. But we can't consider this arrival because M is equal maximum frequency can only be 1. So we'll be discarding this. So again we'll be discarding this as well. Now we completed this set of window size. Since window size is 3, this will be considered, and since it reaches over here, when we move to the next element, we will pop this value, right? So when we pop that value, 2, we are considering only this. L would move forward. Now the first 2 is what we considered for being inside the frequency. So this 2, when we pop out this 2 out, against 2's frequency will become 0. And we can't consider these 2 as well, as I mentioned earlier, the arrivals discarded. Now when we move over, this 2 is what will be accounted. So our 2 is right now, frequency is 1, frequency of 2 is 1. Again we move forward. So when we move forward over here, one thing you got to notice is that we are undercounting the elements. How are we undercounting? We already discarded this element, so it's not in index. But what are we doing is we are directly discarding nums of L without checking if it was already discarded or not. So when we reach over here, this element was already discarded. But still we are doing a nums of L on L minus 1 on it. So this messes up our logic. Now what can be done for this? How can we resolve this, Ravi? So for that, we'll basically keep a very simple, straightforward approach to indicate each and every element is accessed or not, that is discarded or not. So 1, 1, 1, 1, 1, 1, 1, will go on. So initially it's not discarded, so 1 will be that. Now 2, since 2, this arrival of 2 would increase the frequency again, and this increase would be greater than the maximum window value frequency value, so we will discard it. Again, same thing, we would discard it. And we come to this index, and this window will be considered now. And when we move on, this window will be considered, right? When we move on, this window will be considered. Now we will check if this frequency has 1 in it. If it has 1, that is when we will do d of nums of L minus equals 1. But if it's 0, we will just ignore that operation. So accordingly, each and every element would be correctly considered. So this is the idea. Now let's move on to the code base to clearly understand how things work behind under the hood. Before that, the time complexity here would be in time, it would be on. How is it going to be on? Because in the entire array we are iterating exactly once, so it's going to be on. We are not doing any other unwanted iterations, only once we are iterating, so that's going to be on. And space complexity again at worst can be on, because first of all we are already using an array to check if the current particular index is accessed or not, so that would be one on. Along with the sliding window, depends on worst case it would be on. So n plus 2n, on to o to n, but again as per standards on. So this is the approach, that is this time complexity and space complexity. Let's move on to the primarily. We will initialize L is equal to 0. L is what indicates the start of the window, and answer is also equal to 0 for now. And check is what will allow us to figure out if a particular index has been discarded or not, to accordingly shrink the window as per L. Now d is equal to default dict. For those who don't know what default dict is, it's just a custom library in Python for allowing us to insert elements without checking if it's inside or not. And then for the first window size, we run a loop from 0 to w. So for each nums I, we will increment the value in frequency, and then if the frequency is found to be greater than m, that is when we'll start to shrink it. So we'll firstly discard that value, the arrival value itself. So this value will discard, and we'll indicate that this value has been discarded by signifying that particular index in check to be 0. Now since we're discarding, we are incrementing the answer. Now this check, as I mentioned, which will allow us to considered. Now I'll explain you further. So when you run a loop again from that current window to end, here is where you'll have to shrink the window each and every time you move forward. That's why we'll be using a check. So for now, just for simplicity, I'm going to use x is equal to nums of I, and then we'll increment d of x plus equals 1. And the very same code as earlier, just one thing is that we'll be checking if the current index has been accessed or not. So this check will indicate if the check is 1, we will be able to shrink it. If it's not 1, we cannot shrink it. So that's where it's checking it, and if it's 1, we are going to shrink it, as I mentioned, or else we, and always will be taking L forward. And then with each increase, we'll be also checking as checked earlier. So you can just copy this part of code and paste it directly. It should be working fine. So that's pretty much it. You're all set. I guess we can just make a quick check once. Yeah, just one correction is that there was a small typo. It's CHECK, and yeah, I guess that's pretty much it. I can just directly submit it. It should be working fine. And yep. So that's it, guys. I hope you like the video. Would love if you all subscribe, and please do check out my content for further contest.